Hey, good morning, YouTube. This is Content Creation 301 Advanced course here. You notice my green screen in the background. Effort and detail to the haircut. Make sure there's no distractions. Eyeglasses aren't all cloudy. Alright, blast off. So, hey, neighbors, I watch quite a bit of atheist content because I'm an atheist trying to figure out what the hell's going on in the world. That's kind of an atheist nature. I like to think, anyway. Curiosity, how does shit work? So today's atheist conversation is about pollution, aquifer pollution specifically. And the reason I can speak a little bit to this is I serviced a lab instrument inside a research facility that was doing groundwater research using trace elements or tracer elements. Basically, you take a drill hole, put something down there, and then a number of miles away you look for that sample to arrive and time it. So these studies take years or even decades, and someone has to remember what they injected at point A to go down to point B and start looking for it. So inside of this are the physics of molecular flow, how molecules move around the environment. It requires things like statistical analysis because the instrument you have to use to do this. It requires things like understanding what a Gaussian plume is, which basically is if you take and throw a bucket of water up in the air, that water in the air, maybe the wind's blowing or it's freezing out, does some changes and moves away from you. And it's going to fall somewhere. Some of it's going to go into the atmosphere. And that can be mapped as a Gaussian plume. So it's just a mapping thing you can do. If you see where the water fell, you can say a lot fell here and you make it a dark color, and a little bit fell here, you make it a light color. If you can measure it with something, it's even more important. And you get into things like the inverse squared law. So instead of having a general radiation source, inside that, using the incremental measurements you're going to take, you can turn that area, contaminated area, into a point source piece of information. So it could be a square block that's contaminated, and a square block is referred to as a point source. Or if you're on that block, now it's a distributed source. Anywhere you look on that block, it's about the same readings, but you get away from the block and it's back to normal. So everything you do with these instruments requires you to know, understand the physics. If you throw a young earth in there, if you throw creation myths in there, if you throw anything, it breaks the science. It leads you to questions that are unanswerable and truly ignorant because you shouldn't have gone down that path to begin with. You're looking for something that isn't there. It isn't proven there. And this doesn't come from my personal experience. It comes from our extended experience. It's that cumulative group learning. That thing where a bunch of us know more than one of us. It's just the way it works. It's in you. It's not in some external God. There could be a God out there, but it isn't necessary to insert the term or the ownership of the words around the term to a God. A Gaussian plume is a model. It's used for Fukushima. You saw some Gaussian plumes, models. That's where a supercomputer takes and makes predictions about the future based upon what we know about now and the history of what we're talking about, which is decades of study. So you can't stick stupid science in the middle of these conversations. You can't inject ignorant words or words with dual meanings into these conversations. And some people are going to hear one meaning and Other people are going to hear another meaning, and it makes it hard. So this science, these aquifers, they sit down anywhere from, it could be a surface aquifer that's fed with spring water somewhere. You see them coming and going. You know, the water disappears into the earth, goes back underground. Water is one of the best solvents on the planet. So it dissolves things, it moves things. And if you put a geological perspective of millions of years, it begins to make sense how minerals can be extracted from the top of the planet and leach down into underground and create deposits. Or over millions of years, just the dust from the earth and volcanoes and meteorites, millions of years, gently and slowly adds up to the layers that we see on top of how the planet was created. Billions of years going on. You can't throw these perspectives away when you're looking at these measurement instruments. So, yeah, our aquifers are polluted. Exxon did the research with the USGS back in the 80s. I serviced a lab instrument that does this thing. You're talking resolution, elemental resolution out to 9 to 12 decimal places at that time, which was a few decades ago. And we've only gotten better. We're out to, I understand, like 16 or 18 decimal places of precision. So it means a lot. There's a lot going on out there in the sciences that are profitable and very harmful. So back in the 70s, back in the 60s, we learned about pollution and its flow through everywhere in our life. It gets in the atmosphere, it gets in the water, and once it's in the water, it's in the water. You know, you're talking homeopathy levels of stuff. You're talking parts per billion and parts per trillion. But those levels can accumulate. They can add up because over time, these substances move and accumulate and kind of hang out together. And we have the evidence for this. We have the science for this. It happens on a micro and a macro level. If you want to throw those words in there, it happens overnight. So how does an aquifer get polluted? Here's an example. The Hanford plutonium processing facility in Washington State released massive amounts of plutonium and other isotopes into the environment. Some of it airborne, some of it got into the aquifer below the area. And by knowing what was in that groundwater, they were able to go out and look at where the aquifer traveled and find traces of these radioisotopes in other parts of the country that they didn't expect. Miles away, states away even, for some of this analysis. And this was done across a lot of the country. So our aquifers, locations were mapped, the flows were mapped, the regeneration rates were mapped, and all of this was done by the USGS. It is a matter of record somewhere and can be found in the contracts that tie Exxon production research at the time with the USGS and a few other agencies doing this type of analysis. So the shit's there. This was cray supercomputer land at the time in the 80s when those were the monsters to have for crunching numbers. Exxon had a map on the wall of all the aquifers in the North Americas that were known at the time. These were the deep water aquifers, and we've only improved that understanding. Not said, oh, we were wrong then. So this buildup is measurable. We've got reference materials and history. Some of those samples might be around for better analysis today to see how much we've polluted these aquifers. The aquifers matter because they're watering the bread baskets of America. They're watering our cornfields and our rice fields. We're pumping this water out of the middle of the desert from deep below the earth that won't get replenished for another million years. These are natural resources. These are the fundamental resources of life, and this is what the big boys play with. This is why they can sell you water in plastic bottles for $1 a liter or something and get away with it. and you don't know if their water's safe. They're not doing the tests as well. You have no idea what's in your drinking water unless you see elemental analysis and hydrocarbon analysis and 6 different series of assessments. You don't know. So this is the world of high precision measurements. I understand that very well. How you get something into an instrument for the analysis is a story of chemistry and molecular reductions and a whole bunch of science that I'm aware of, but that's not my specialty. I do know once that sample is put into the machine that the machine is going to say what's in that sample and what elements it will report out or is capable of and to what precision. So here's a rambling. Next part of the conversation, though, is the instruments themselves. Every instrument has physical characteristics. You characterize and you qualify and quantify an instrument. When you qualify it, you say exactly what can this instrument measure. Once it's qualified, that's the rules. Unless something else changes that you have to take a channel or add a channel or something in or out of that for a reason, then that gets documented. Or maybe you had the wrong channel you used for 6 years and you're upgrading to new channels. You need to keep the data relevant, and you can statistically or you can mathematically, but you've got to keep that record of the changes that you made, blah, blah, blah. It's called a chain of custody for a sample that includes all the instrument data. So what can happen in here is an instrument might be able to measure out in parts per billion or parts per trillion very easily. But if the instrument is set for legal reasons to measure minimum control levels, MCL, or the certifications for the instruments, the lower control limits for measurement stability or measurement error are a part of that. So the report from an instrument might not actually tell you what the instrument saw. It might be an analysis of what the instrument saw, and whoever's doing the analysis for a lot of reasons can ignore data. And you can ignore it with confidence because it's statistically insignificant. Why does that matter? Well, let's get into biological uptake. Every food you eat is going to reside in your body for X amount of days. There's a rule for almost every element that enters your body, and it depends on if these pollutants we're talking about, what kind of mimickers they are. They can be molecular mimickers, which is most organic pollutants, the PCBs, all of those long chain things that cause cancers that we've heard about. So that's a different analytic technique to find those. Elemental analysis speaks to the periodic table and the isotopes associated with elements. And those numbers, so say they're below the minimum control limits, so they don't need to be reported. But there are only a few points under those control limits. Unless you take into account biological uptake, like cesium is a calcium mimicker, and it has a long half-life in your body. So once you eat it and digest it, it goes into a bone and hangs around there. Some of it goes to your heart muscles, which is even more interesting. And this is all science. You can go find this. I'm not going to give you references to that. You can find it. It's just a fact. It's the stochastic outcome of nuclear pollution. And that word stochastic, yeah, look it up. Hey, reply, ask a fucking question. We measure the shit out of stuff. The measurements are trade secrets, they're industrial secrets, they're federal secrets, they're nuclear waste secrets, because when you know about them, it either gets scary or you have knowledge that can harm a lot of people. And we are harming a lot of people with pollution. So your next step after the atheist stuff and the God stuff and throwing that fucking Bible away is to go look at some science. Pick a domain. Pick a domain anywhere. Earth sciences, life cycle sciences, You could go into the financial aspect and look at how a life cycle is built up in business versus a life cycle built up in nature, and realize how broken our life cycle analysis studies are. These are things like, mean time between failure studies and where those results go. They are risk analysis. If this nuclear plant blows up, we are going to raise cancer rates in an area, period. It's not a debate. It's not a question. It's a matter of how much. How many generations? This is nuclear. This is generational, not ignorant today's profits. And my return on investment is super. I love the stock market. These people are stealing our lives. So lose the Bible. Don't read the book. Ignore it. It's not necessary. It is almost irrelevant except for some of the few moral values you can get out of there. What is important is that community that lives around that and lives around pollution. And those two things side by side can be dangerous. So yeah, hey, Happy New Year, folks. I think this is my first one this year. You can tell I'm definitely going for Patreons here. And I'm just going to up the quality of my videos bigly, because that's what matters. Thanks. So neighbors, I use the term neighbors because honestly, this is the internet. Till we get to meet or know each other, we're neighbors. But hey, come near the fence. What the hell? It's a big world. Enjoy. Love my grandson.